Your phone's keyboard knows your best friend's name. Type 2 letters and there it is, floating above the keys. No one put it there. The keyboard watched you type, and it learned. The AI you talk to speaks whole languages the same way, and it learned them from more text than the largest libraries hold. But open it up, and there is nothing to read inside. No rules, no dictionary, just billions of numbers. Numbers that somehow speak English. Nobody wrote them, so where did they come from? This is Owlspect, Chapter 3 of How a Machine Learns to Talk. First, the engine room. Every word the machine writes is picked from candidates, and each candidate gets a score. Picture a little skyline of bars. Today, no one ever sat down and typed in those scores. So what did? Worth a closer look. Pick any number in there. It isn't a word. It isn't a rule. Not one sentence of English is written anywhere inside, and no single number means anything on its own. Whatever speaks English in this machine isn't written in any one of them. It's in the arrangement. Billions of numbers in long rows. And that is the entire machine. Engineers call those numbers weights. Picture them as billions of tiny dials, each turned to some position. Ask it what comes next, and it's the dials, all together, that produce every score in the skyline. And fresh from the factory, every dial sits at a random position. The machine begins as pure static. Something turned billions of dials to exactly the positions that speak English. What turned them? That's what we're here to find out. The method is almost embarrassingly simple. Collect text. A mountain of it. Books, articles, conversations, code. Show the machine a snippet and hide the next word. Then ask the only question it ever answers, the question from Chapter 2. What comes next? On day 1, the guess is garbage. Take a snippet any child could finish. Happy birthday to. Random dials, random skyline. It's 3 guesses. The, 7, and a chunk that isn't even a word. Then comes the move that makes the whole thing work. Reveal the real word. The text is its own answer key. Whatever word actually came next is the correct answer. Free, already sitting in the sentence. Here, the real word is you. Now measure the miss. The real word wanted a tall bar. How short did it fall? What happens next is the entire trick. The miss flows backward through the machine. Every dial turns a hair's width. Each turns in the direction that would have made the real word a little more likely. It isn't fixed, just a little less wrong than before. You've seen this loop before, running the other way. Writing reads the dials to pick a word. Training uses the word to turn the dials. The error is the teacher. And the pile holds millions of birthdays. Every time one comes past, the machine guesses, misses a little less, and turns its dials a little finer. The bar for the real word creeps up. No one ever explained it. It just kept missing, and every miss left a mark. This game is the training. It is the machine's first school, and by far the longest. A finishing school comes later in the season. Then the next snippet brings another guess, another miss, another hair's width turn. Now let it run. Trillions of hidden words. Weeks or months of this, on thousands of machines, doing nothing but this one tiny step. No single nudge teaches it anything at all. The patterns only wear in across a trillion of them. Watch the skyline learn, sped up. It finds the cheap habits first. Letters that travel together, spaces, endings. Whole words come next, and grammar clicks into place. Facts, tone, and style are worn in last. The expensive habits. Roughly that order. Cheap patterns first, because cheap patterns pay off first. The grammar was worn in, the way water carves a riverbed. A billion small pushes, each one almost nothing. The dials are the riverbed. Everything it had read flowed through, and the shape the flow left behind is what stayed. Keep that picture. The whole season leans on it. And a riverbed is deepest where the water ran most. Ask about something the internet has said 1,000,000 times, and the machine glides down a deep, sure channel. Ask about something said twice. The water barely scratched the stone. You felt this. Common questions come back solid. Obscure ones come back confident and wobbly. Then one day, the training stops. The dials are locked in place. The machine you chat with was carved months ago, sometimes longer. Out of the box, it is not learning from you. Your conversations turn none of its dials. It's also why the machine can be brilliant about history and blank about last week. The carving has a date on it. Chat products can bolt on a search of today's web, and and notes about you, but the machine underneath stays frozen. It has read more text than the largest libraries hold. Every page went through the same game, one hidden word at a time. And there's no warehouse in there. The answers aren't stored. So what exactly did it keep? Did it just memorize the internet? Do the arithmetic, and the warehouse falls down the second time, on its own. Printed out, the text some of these machines have read would fill a library of tens of millions of books. The machine itself, every dial it owns, would fit on a single hard drive, with room to spare. The pages cannot fit. They were never kept. What survived is the residue. Which word follows which, and which words travel together. A library, reduced to its habits. You can watch the residue work. Somewhere in its reading were thousands of cookie recipes. Ask for any one of them, the exact recipe from one page, one site, and it's gone. The page was never kept. Ask for a cookie recipe though, and one arrives in seconds, smooth, plausible, and new, built from the habits of all of them. One honest exception. Show it a passage often enough, and the habit becomes the page. Famous quotes, song lyrics, code that half the internet copied. The machine can sometimes give those back word for word. Researchers have even fished out passages it met only a handful of times. Measured against everything it has read, rare, but real. And one thing nobody can do yet, including the people who built it, point to the exact dials that hold a single fact, say, where Paris is. It's in there, spread across countless dials, no one of them decisive. Which also means nobody can simply read the riverbed. There's a whole science learning to. We'll spend a chapter inside it at the end of the season. So, one guess, one miss, one nudge at a time, repeated until the patterns of a language are worn into the dials. And now you know where the scores come from. Nobody wrote them. They were carved. They were carved by a single question, the same one the machine answers every time it writes. What comes next? You've played this game yourself, by the way. Every time a text comes in and you guess the word under the preview before you open it, that's one step of the training game running in your head. And the keyboard from the start has been playing it all along. Every suggestion it's ever floated above your keys came from a tiny skyline, sharpened on your typing. All along, we've been saying the machine learned the patterns. Patterns of what exactly? Inside the machine, what does a word even look like? It isn't letters, those got sealed away. For king and queen to sit close in meaning, the machine needs something no dictionary has. Next chapter, we crack open a token, one of the word chunks the machine actually reads. There's a map inside. Room 3 of the machine, lit. It can read. It can write. Now you know how it learned too. This was Owlspect, Chapter 3 of How a Machine Learns to Talk. We make the invisible parts of AI visible.